increase. So a little bit about the challenge for the near future. And so the demand, this is a little bit harder to see here, but to the bottom we have coal, and then oil, then gas, and then the top four here are nuclear, hydro, and biomass, and other. And so as you can see, the demand is continually rising, which is no big surprise. The problem that we get into is that in the energy supply is going to be sort of capping out on fossil fuels around 2015 to 2025. And so we're going to have to come up with some other alternatives to help pick up the slack. And so through that, energy costs will probably continue to rise as well. So let's focus more on the business challenge. So, energy is a large unmanaged expense. There's little visibility into it today. Office, IT, and data centers are consuming more energy than needed, so the demand is continuously increasing. There's little integrated ways to measure and report. There's a lot of disparate systems, if any, that exist. A couple of points to note on the pie charts here is probably no big surprise, but heating, cooling, and ventilation are going to consume more than half of your consumption in an enterprise. IT equipment's here, maybe anywhere from 25 to 40% in a given environment, again, depending on the industry. This is kind of an interesting statistic here. They say that 50% of PCs left on overnight are wasting $2.8 billion. It's a lot of money there. This pie chart, this is the data center use. So, cooling is a big factor, of course, and then the IT equipment here. And if you can find ways to save energy to reduce IT equipment consumption, then obviously that's going to have effect as well on the cooling. Another statistic here, they project that 15% of servers in an enterprise are doing nothing, essentially nothing. And so it's about $25 billion worth of waste. So there are a lot of unknowns, many unanswered questions. How much power is being used? By what devices? And why is it being used? We need to get intelligence. We need visibility. Who are the biggest consumers and why? And also, do you know where your power goes? I like to use the home as an example of lack of visibility. It wouldn't be nice if you had a system that you get your energy bill on a monthly basis. If you had something that could break down granularly in your house to find out what's being consumed and when. Maybe it's the Xbox machine is running all the time, or the coffee machine, or something like that you have no idea really it's consuming. It's just sort of take it for granted, but maybe it's costing you $1,000 a year. If you have that type of information, it might start modifying some behavior. So we get the electric bill every month, and again, we're not sure what are we paying for. We can also, it's easy to be motivating if you get that visibility. Now, one analogy that we like to talk about is leaving your car running in the driveway, and it's you'd sort of take it for granted. Well, no, I wouldn't do that, and no, you wouldn't leave your water running if you're not using it. No, you wouldn't leave your lights on throughout your house all night if you weren't going to use them. So, in essence, why are you going to let your IT equipment just run and run if it's not needed or not needed fully? So trying to find some ways to maybe reduce some consumption. So a little bit about the energy management challenges. So there's no single energy management system across domains, and the way we break out domains is into three main categories. Distributed office, where all your knowledge workers are, your plug load, your IT plug load. Data centers and all those type of devices, and then of course facilities with your HVAC and lighting and things like that. So, things are consuming 7 by 24, 365. Again, I mentioned it's hard to, measure and manage. Something else I like to point out is it's a lack of accountability and visibility. Um, people really, it's all about uptime, reliability, and performance, but there's just no visibility on how much you're consuming. And if you have that visibility, then there's going to be some accountability on how they're using it. Users generally don't turn off equipment, and it's difficult to identify top energy hogs and power-constrained data centers as well. We can help find stranded energy. An energy management system can help find stranded energies in a data center. So rather than having to expand or maybe build a new data center, why don't we try to capture some of that back to delay that infrastructure expense? So what can we do with an energy management application? The first thing we're going to do is we're going to gather. We're going to get a baseline your energy consumption. So we're going to gather consumption and utilization information. Old saying here, you can't improve what you can't measure. So we're going to do baseline your energy consumption, and there's a lot of information we can gather doing that. So you can do, monitor by day and by time, by geographic location, by business unit, by department, by floor, by data center, rack density, device type. So there's a lot of different ways that you can, or a lot of different information you can collect here. So this chart here is just an example of power demand. So again, this could be, a Jülich application or other types of applications. Just, throwing these up for example for you. So the next step is to identify your savings opportunities. So, you want to analyze energy consumption and the device utilization. So you look for usage patterns, see what appears, and start doing some simulations, some what-ifs. Well, what if I did put this policy in place? How much money could I save? How much energy could I save? Look for servers not being utilized or underutilized or lack of rack density. Or, look for patterns on, the knowledge worker devices. Are they running all night? Are they running on the weekends and holidays? Look for opportunities there. So this chart is a little bit about the power consumption, and here's the utilization. So trying to correlate that and see how that looks. So the next step is where the ROI comes in. So you can create energy savings policies. So, get some quick wins, save money quickly to get the project moving here. So examples are, retire dead servers, virtualize. I know a lot of organizations have virtualized, but there's probably still opportunities to do that as well. Making sure you're getting proper rack density. And again, we talked about this last time, actually start powering down PCs, monitors, phones, and things like that on weekends, nights, and holidays. So the next is to report the savings. So this is where, your executives, your sustainability officers, your customers, your shareholders, all will appreciate the green messaging, and the executives, particularly CFO, will actually appreciate the ROI as well. So you can report on cost or power or CO2 saved. So this slide here, we're talking about, again, I'm sorry for the slides, the screenshots being so small here, but it's the saved energy here, saved money, saved CO2 emissions. The chart down here is the blue is the baseline. So this is what you have been consuming, and the red is the savings. So the gap between the two is the savings. So a little bit about how we can do this. So there's methodology that we'll break into three parts. So the first step is to monitor. Again, measuring the energy consumption and utilization of all your devices in those different categories that we talked about of distributed office, data center, and facilities. And then after you gather that information, you can do some very, very powerful analytics to get this information here and start looking at energy costs and usage patterns and carbon emissions. And so just giving you all this information, you can start making decisions, which is where you come over to control about deploying policies. So you might do events-based policies. Could be time-based, or it could be perhaps you have some peak load capacity pricing that kicks in if you exceed a certain level. Why don't you have an alert that says, hey, we're going to exceed this, let's throttle down some non or low priority devices, and when we get past that time frame, then let's release those, and then they can go back to full utilization. Could even be PCs. Let's put those in a lower power state during this peak capacity period. So you can do rule-based as well as the simulations I mentioned. Also, there's one that's not on here. It's sustainable procurement. So there's some reports where you can actually compare like devices in your environment. So whether it's PCs or servers or printers or switches or routers from the same vendor or different vendors, where you can actually compare those devices for energy consumption, operating expense, rather than just making the decision on the capital expenditure. We can now have a little information on an expense perspective and compare those. So what is the future going to bring? Well, we have an explosion, which I'm sure that the folks that are on this call understand. A lot of increases, and it's going to only continue. If you can just imagine 5 years ago, just on a couple devices like iPads and smartphones and things like that have increased. But from a business perspective, there's all sorts of needs that are going to be out there that are going to get fulfilled by connecting it to the network. So here's an example of a slide that's not populating here. Well, the example was going to be to show that a user comes into a building, and what it'll do, it'll turn on the devices that are associated with that user. And the way they can do this is it could integrate with a badge management system, or it could integrate with an application that's on a smartphone. So, for example, an iPhone or a BlackBerry or an Android. And through the GPS, it'll see that that person is coming within a half-mile perimeter, and it will then fire those devices up that are associated with that user. So the PC and the monitor and the phone, and then might fire up the lighting on a floor if they're the first user in, and adjust the thermostat. So this can be done via a batch management system or a GPS on an iPhone or a BlackBerry as well. So here's an example of just what that application would look like on an iPhone. So you can utilize the GPS so that becomes automated, or you could actually do powering on and off yourself, or have your own little mini dashboard on consumption and savings and CO2 emissions. So just to give you an idea of what that application looks like. So the second piece of this slide, which is not populating here, but is about when that user leaves the building. So they slide their badge through the reader, or they're leave like that half-mile perimeter. Then it will power all those devices that are associated with that user into a standby or hibernated or off state, whatever state that you decide to do. And it may then turn off the lights if they're the last user on the floor. And it may lower the thermostat. So just giving you an idea of what all can be done with an enterprise energy management system. So how do we do this? So, whether it's us or any other energy management application, we're going to try to leverage your network, leverage your existing management system, the existing protocols that are in place in an organization to provide this functionality. So the type of the devices that we're talking about, in the distributed office, we talked about desktops, but it can also be access points. Phones actually are usually on 24 by 7. And folks, I know they're not big wattage users, but if you scale them for an organization that has thousands of phones, it can start making some sense and adding up to some dollars there. Giving you visibility on standalone printers versus network printers. The data center, you can have all those type of devices in there, whether they're blade servers or just servers or even virtualized servers. UPSs, PDUs, CRAC units, storage, and then on the facilities side, of course, your biggest users or consumers are HVAC and lighting, and then also even video camera systems. So a little bit more detail about how this is done. So in just giving Julex as an example here, it would sit in your data center behind your firewalls, Julex Energy Manager. And what it's going to do is to leverage your existing infrastructure. So, for example, if you had Cisco networking gear or Juniper networking gear, we have connections into those management systems to be able to actually communicate with those devices to gather consumption and utilization information. And that type of, those devices, you're probably just collecting information, just monitoring, not doing a whole lot of control. There's some folks over in Western Europe that are starting to look at load adaptive network computing, where they can actually throttle down those devices a little bit based on the actual utilization that's going on. Maybe at nighttime it's a little less. It's a little aggressive policy, but where power is becoming more expensive, they're looking for ways to reduce. Another example is Microsoft has an application called Active Directory. So you can tap into that, collect all that asset information in all the PCs, and then communicate to those devices via Windows Measurement Instrumentation, WMI. So not installing any agents out there on these PCs, which become a nightmare just from a QA and testing perspective and deployment, but just tapping in via the existing management systems and protocols that you already have in place. On non-IP devices, you could tap in via either meters, existing meters that are in place, or some gateways. Example of a gateway would be from Field Server, where we could implement that device, and it converts non-IP type of protocols, BACnet, LawnWorks, and Modbus, into IP-centric traffic, so that you can report and analyze and read that type of information. So those are just some examples. There's a lot of different ways, to tap into existing devices, whether it's SNMP or, Intel DCM and things. So the final slide that I have is just, this is just a dashboard, so you can see what kind of information you get. So viewing the energy from the edge to the core. With a dashboard, you're having high-level information. So you could be reporting on geographic locations and how much you're actually consuming in those different areas. Here's a PUE, it's for data centers, power usage effectiveness, showing what kind of statistics you have in there. This might be, by device granularity, where you can break it out and show what kind of devices are on. Here would be the power meter, kind of current and max demands that are going on. Here's the demand that's going on in the day. Here's a consumption map that shows on different days. This is Monday, Tuesday, Wednesday, and different times, and showing how much that is being consumed at different times and different days, so you can start looking at patterns. Here's a consumption by location. And again, I'm sorry that this didn't get large enough here, and shows you, what your costs are by the locations. So that's, the example of a dashboard, and that concludes my presentation here. And